Hello students, welcome you to this session. In this video, we are going to see composition of functions. Composition of functions. You know what is functions, right? You studied already. Cartesian product, or we call it as cross product, that is set of ordered pairs. If you take few elements and you form a set, that is called relation. A relation is a subset of Cartesian product. Then a relation becomes a function under two conditions, right? Every element of the domain must have an image. It must have only one image. Then you know there are different types of functions. Okay. Then you know there are some operations. In number system, if we have two numbers, you can add them, subtract, multiply, divide. Same way, if we have functions, f and g are two functions, you can combine them using this operation called composition. So we are going to study that in detail today. Okay. So composition of function, it is an operation which combines two or more functions. Suppose there are two, we take two functions and assume three sets. Suppose A is a set, B is a set, and C is another set. There are three sets. F is a function from A to B. F is a function from A to B. And we assume G is a function from B to C. F and G are two functions. I'm taking an element from A. Let X be an element in A. Its image under F will be in B. That is F of X. That is the output of F, right? When you give X to F, it will become what? F of X. Now, this is the input for G, because G is the function from what? B to C. If we give this F of X to G, the image will be, the output will be G of F of X. And that G of F of X only, we denote it as G composition F. So G composition F of X means, don't find G of X first. First you have to find F of X. First you find what? F of X. First you find F of X. Then that you put it in what? G. So yeah, G composition F of X means G of F of X. What's the meaning? It is G of F of X. Same way, what is F composition G of X? F composition G of X means F of G of X. First you have to find G of X, that you put in what? F. Okay. Now listen here, there are some properties. When you find F composition G and G composition F, they won't be equal in general. Generally, F composition G is not equal to G composition F. What's the meaning of that? It is not commutative. The meaning is what? It is not commutative. So you can say composition of functions. Composition of functions is not commutative in general. But there are some cases there it satisfies what? F composition G equal to G composition F, it may be commutative in some cases only, but in general, it is not commutative. Okay, so this is one property, composition of function is not commutative. Then later we are going to study sums. Composition of function is associative. What's the meaning of associative? Grouping, right? We need three functions. For example, we have three functions, F, G, and H. F, G, and H are three functions. Then you find F composition, G composition H, and F composition G, composition H. So you can understand the difference. Grouping. Here G and H we are grouping. G and H we are grouping. Here we are grouping what? F and G. In any case, you can see they are equal. Okay, so F composition G composition H is equal to F composition G composition H, and this property we call it as what? Associative. So composition of functions is associative. later we are going to do sums using this. So all those are 5-mark questions. Okay. So that's all the theory part about composition of functions. Now let us see how to find F composition G, G composition F and all. Okay. So please listen carefully. So look at this question. So here what is given? Using the function F and G given below, find F composition G and G composition F. Check whether F composition G equal to G composition F. They didn't ask you to prove they are equal. They asked us to check whether they are equal. Okay. So two functions given here. F is a function. F is what? X minus 6. F is X minus 6. And G is what? X square. So first we are going to find F composition G. F composition G of X we write. F composition G of X. How can I write F composition G of X? F of G of X, right? F of G of X. That is F of, what is G of X given here? G of X is what? X square, right? So write it as what? X square. Now put this X square in what? F. You have to put this value in what? F. So what is F here? You see, what is F? F of X is what? F of X is what? X minus 6, right? X minus 6. F of X is X minus 6. F of X is X minus 6. Instead of X, you put the value. What is that? X square. So we want F of X square. That means you put this X square, you put this X square in what? F. You put this X square in what? F. So what is F here? F is X minus 6, right? X minus 6. So you put a bracket. X minus 6. Instead of X, you write the value X square. So you cannot simplify. So the answer is what? X square minus 6. So this is F composition G. Next, let us see how to find the right side. What is the right side? G composition F, right? So now we are finding G composition F. So G composition F, you write G composition F of what? X. That can be written as G of F of X, right? That is G of F of X. What is F of X? That is given here, X minus 6, right? X minus 6. That X minus 6 you write here, X minus 6. This X minus 6 is substitute in G. This X minus 6 is substitute in what? G. What is G of X? G of X is what? X square. X square. Instead of X, you write the value. What's the value? X minus 6. So X minus 6 the whole square. You know how to expand it. This is A minus B the whole square. What is A minus B the whole square? A square minus 2AB. So 2 into 6, 12. So 12x plus B square. What is B square? 36. So both the answers you got it. This is equation number 1 and this is equation number, so this is equation number 1 and to make it as equation number 2. So are they equal? No, right? So what conclusion you can say from 1 and 2? From 1 and 2, F composition G is not equal to G composition F. So they asked us to check whether F composition G and G composition F are equal. So we got both the values and we got both. They are not equal. Okay. Now we go for the next question. Look at this question. Here what they asked, using the functions F and G given below, again, find F composition G, G composition F, check whether F composition G equal to G. Similar question. So it's for you to practice one more question. Let us find F composition G here. For that, F composition G of what? X. That is F of G of X. That is F of, what is G of X? G of X is 3 minus X, right? G of X is 3 minus X. Put this value in what? F. But what is F here? This is F, right? F is X plus 6 by 3. X plus 6 by 3. X plus 6 by 3. Instead of X, you give the value. What's the value? 3 minus X. Okay, 3 minus X. So simplify what you're getting. 3 minus X plus 6 by 3. Group the like terms. So what you're getting? 6 and 3, right? So it is 9 minus X by 3. So this is the value of what? This is the value of F composition G. Also, we have to find what? G composition F. Okay, so we find G composition F of X. can be written as g of f of x. That is g of, what is f of x? F of x is x plus 6 by 3, right? Just substitute the value, x plus 6 by 3. Now, very important step, this value you substitute where? In what? G. So see, what is G here? What is G? 3 minus x. What is G? 3 minus x. Instead of x, give the value. What is the value? X plus 6 by 3. Now take 3 as LCM. When you take 3 LCM, 3 into 3, it is 9. Minus of this. So by minus, you multiply both. So what do you get? You get minus x minus 6. So listen, like terms, 9 minus 6, it is what? 3. So you are getting 3 minus x by 3. 3 minus x by 3. So F composition G got one answer. G composition F another answer. Are they same? They are not equal, right? So they are not equal. So again, you can say the conclusion. What conclusion from 1 and 2? F composition G not equal to G composition F. Now we go for another question. Look at this question. Find the value of k. They asked to find the value of k. Different one, right? Find the value of k such that F composition G is equal to what? G composition F. I said, not in general, they are not equal. But here they are telling they are equal. Such a way you find the value of what? K. What is given here? Fx1 function, g of x another function, but there is an unknown. What's unknown? K. They asked us to find the value of that k only. So what do you do? Usual method, you find both F composition G and G composition F, and here we equate that. Okay. So first we find F composition G of x. That is F of G of x. That is F of, what is G of x? 6x minus k, right? G of x is 6x minus k. Now put this value in F. Read what is F? 3x plus 2. 3x plus 2. Okay, so if you do like this, you won't make mistake. Instead of x, you write the value. What is that? 6x minus k. Expand it. So 3 6 are 18x minus 3k plus 2. Can you simplify this? No, right? You cannot cancel anything because there is no like terms. So this is F composition G. Next you find what? G composition F. So for that, G composition F of x can be written as G of F of x. That is G of, what is F of x? It is given 3x plus 2, right? So 3x plus 2. Now put this value, this 3x plus 2 in what? G. So see what is G? This is G. 6x minus k, right? So 6x minus k. Instead of x, you write the value. What's the value? 3x plus 2. Substitute by this 6. So what you get? 6 3s are 18x plus 6 2s are 12 minus k, right? So multiply these 6 into 3x, 18x plus 6 2s are 12 minus k. Okay, both the values you got it, right? Now you see what they given in the question. What is given in the question? It is given. So it is given in the question F composition G is equal to G composition F. Both the values you got it. What is F composition G value? This is F composition G. So 18x minus 3k plus 2 equal to G composition F. What is that? That is 18x plus 12 minus k. So can you find out anything cancel here? In both the sides, you can find 18x, right? So this 18x and this 18x also cancel. So once you cancel these two, so what do you get the remaining? Minus 3k plus 2 is equal to 12 minus k. Combine all the k terms together. Minus 3k plus k. Bring that minus k to the left side. Here 12, take this 2 to the right side, it becomes minus 2. So you are getting minus 2k equal to 10. Change the sign on both sides. So 2k is equal to minus 10. K is equal to minus 10 by 2. You are getting k is equal to what? Minus 5. This is what they asked us to find, right? Find k value so that F composition G and G composition F are equal. Okay. Shall we go for the next question? Look at this question. Here again, two functions given, f of x one function, g of x another function. Show that they asked us to prove, right? Show that f composition g, g composition f, both are equal and each equal to x. So you have to prove two parts. What are the things you have to prove? You prove f composition g equal to x. Also, you prove g composition f is also x. Answer given, just a revision, you can do very easily. So first you find f composition g of x. That is f of g of x. That is f of, what is g of x? It is given x plus 1 by 2. Now we know, put this value in what? F. So what is f here? 2x minus 1. So 2x minus 1. Instead of x, you write x plus 1 by 2, right? So here 2 and 2 get cancelled. So you are getting x plus 1 minus 1 because this 2 and 2 get cancelled. So now this plus 1 and minus 1 cancel. What's your answer? X. So this is the answer for the first part. Now they asked, we had to find one more part. What did you find next? You find g composition f. Same way, g composition f of x can be written as g of f of x. That is g of, what is f of x? 2x minus 1. Put this value in g. What is g? What is g here? X plus 1 by 2. X plus 1 by 2. X plus 1 by 2. So that is equal to, sorry, here you give the value. What's the value? 2x minus 1. So you are getting 2x minus 1 plus 1 by 2. You can cancel this minus 1 and plus 1. You are getting 2x by 2. Again cancel 2. You are getting x, that is 2. So now again you can say from 1 and 2. In this case, you are getting both answers are what? Same. F composition g equal to g composition f is equal to x. This is what they asked us to prove. It's a very simple question. Now we go for another question. Find the value of k. Find the value of k so that f of k, they given f of k is equal to what? 2k minus 1. F of k is 2k minus 1. F of k is equal to 2k minus 1. Instead of x, they given a k. That's all. And f composition f of k, they given us what? 5. F composition f of k is equal to 5. So let us find f composition f of k, then equate with 5. So you find f composition f of k. Normally they give two functions, right? F and g. But here only one function given, f. And they asked us to find f composition f. In both the cases, you use f only. So you can write it as f of k. F of k. That is f of. What is f of k? It is 2k minus 1, right? It is 2k minus 1. Now, you have to put this value. You have to put this, this 2k minus 1 in what? F. What is f here? F is 2k minus 1. So, 2k minus 1. Instead of this space, you have to put this value. What's the value? 2k minus 1. Expand it by 2, you multiply 2 2s are 4. So 4k minus 2 into 1, 2 minus 1. So you are getting 4k, right? 4k minus 3. But what is given in the question? It is given f composition f of k equal to 5, they said, right? So you know the value of f composition f, that is 4k minus 3 is equal to 5. So 4k is equal to 5 plus 3. Minus 3 take there, you'll get 8. Or k is equal to 8 by 4. You are getting k is equal to 2. Okay, so the answer is k is equal to 2. So now we go for the next question. Little different question. See what they asked here. A, B, C are subsets of n. You know what is n? Set of natural numbers, right? N is set of natural number. F is a function from A to B, and G is a function from what? G is a function from B to C, right? B to C. F is a function from A to B, and G is a function from B to C. Fx they defined. Fx they defined as 2x plus 1. Fx is 2x plus 1. And g of x they defined as x square. What they asked here, they asked us to find the range, right? Find the range of find the range of F composition G and G composition. So what we do first, we find F composition G. I'll tell you how to write range. Then we find G composition F. We will write the range of G composition F also. Okay. Range means the answer belongs to which portion. Okay. Which area, which set that we write. So first you find F composition G. So for that you find F composition G of X. Here what is X? X is a real number, right? So both F and G are functions. F is from A to B, G is from B to G. In all these sets, A, B, C, everything subset of N only. So X is a natural number. So this can be written as F of G of X. That is F of G of X. What is G of X? It is X square. Now put this X square in F. What is F? F is 2x plus 1. 2x plus 1. Instead of that, you write X square. So you are getting 2x square plus 1. So this is F composition G. Now we see how to write range of F composition G. So we write range of F composition G is equal to set of all y. Set of all y such that y is equal to, y is the image. This is the answer. What answer you are getting here, you write. What's the answer you are getting? 2x square plus 1. And you mention x belongs to what? N. This is how you have to write the range. Usual method, you find what? F composition G, you find out. What answer you are getting? 2x square plus 1. But when you write the range, range is equal to set of all y such that y equal to that answer you write 2x square plus 1 and x belongs to N. So this is F composition G and its range. So next we find what? G composition F and the range of G composition F. Okay, so let us see how to find G composition F. So now we find G composition F of X can be written as G of F of X. That is G of, what is F of X given in the question? 2x plus 1, right? 2x plus 1. This 2x plus 1 you substitute in what? G. What is G here? G here, it is what? X square. X square, right? So you are getting 2x plus 1 the whole square. 2x plus 1 the whole square. If you want, you can expand it. Anyhow, you cannot simplify or you can leave like that. But now we write range of G composition F. That is equal to, like previous one, set of all y such that y is equal to the answer what you got. What's the answer you got it here? 2x minus 1 the whole square, right? So 2x plus 1. 2x plus 1 the whole square. Don't stop here where x belongs to N. This is how you have to write range. Okay. So you know how to find F composition G and G composition F. Now how to write the range. So another question we see. A function given f and g are two functions. F of x is defined as, f of x they defined as x raised to 5. And g of x they defined as x raised to 4. And both the functions are from R to R. R to R. What is R stands for? R stands for set of real numbers. What are real numbers? It is a union of rational and irrational. That means it includes all the positive values, negative values, zeros, all the decimals, fractions, everything together, except imaginary numbers. All other numbers, all are what? Real numbers. Okay. F is a function from R to R. So for domain, you can take any real number and your answer also some real number. And here, what they given here, two functions, f and g, they defined. What they asked to check? Check whether f, g are 1, 1 and f composition g is 1, 1. So they asked us to check three things. Which three? F, g, f composition g. They asked us to check whether these functions are 1, 1. What is 1, 1? How can you check the function is 1, 1 or not? If two different elements must have different images, right? In domain, you take any two elements, they should not have same image. Their images must be different. Then only you can say it is what 1, 1. So two different images you take here, two different elements you take in the first set, you find out their images. Images also must be different. Then only say it is what 1, 1. When we say it is not 1, 1, if it is not 1, 1, it is many 1, right? Suppose some elements are here, some elements here. So first element is related to a particular number. Second number also related to the same particular number. Then we say what? Two different elements have same image. Then it is not 1, 1. So this is what you have to check here, okay? So to check it is not 1, 1, just to show one example. Two elements you take, find out the image. If the images are same, you say two different elements have the same image, so it is not 1, 1. Okay, if it is 1, 1, no need write. You cannot write everything, no. So you write in general the words. You can write here two different elements. The different elements have different images, so the function is what 1, 1. Like that, you can write the answer. No other calculations here. So first we check whether f is 1, 1. So first we are going to check whether the function f is 1, 1. Okay. So what is f here? F of x is what? X raised to 5. F of x is x raised to 5. Listen, we take two different elements. For example, I'm taking f of 1. What is f of 1? 1 raised to 5. What is 1 raised to 5? 1. F of minus 1. F of minus 1. For x you put minus 1, right? For x you put minus 1. For x if you put minus 1 raised to 5. Minus 1 raised to 5. Minus 1 raised to 5 is minus 1 because minus 5 times. So it is what? Minus. So for 1, the image is 1. Minus 1, the image is what? Minus 1. For 2, what's the image? If you put 2, 2 raised to 5, 32. If I put minus 2 raised to 40, minus 2 raised to 5. Minus 2 raised to 5. First 2 raised to 5 is 32, right? F of 2. 2 raised to 5, 32. If I put minus 2, f of minus 2, that is minus 2 raised to 5. Minus 5 times, so it is minus. So the answer is minus 32. So different elements have different images. So you say the function is what? 1, 1. So here you can say, you can just here to write, here different elements have different images. So f is 1, 1. Okay. So different elements have different images. Therefore, f is 1 to 1. Now, next what you have to find, we have to check whether g is 1, 1, right? We have to check whether g is 1, 1 or not. So for that, what is g of x? X raised to 4. Okay, so g of x is x raised to 4. G of x is x raised to 4. Now we see whether this is 1, 1 or not. So give some example. You give g of 1. What is g of 1? 1 raised to 4. What is 1 raised to 4? 1. You find g of minus 1. What do you get? Minus 1 raised to 4. Minus 4 times. So minus 4 times. It is plus, right? So here also you are getting what? 1. Both answers are same. What's the meaning of that? Here 1 is here, minus 1 is here. In the answer place, 1 is related to 1, minus 1 is also related to 1. So different elements have same image. So it is not 1, 1, right? So G is not 1, 1. G is not 1, 1. So two things we checked. F is 1, 1 or not. F is 1 to 1 only. But G we checked, right? So we got G is F is 1 to 1, but G is not 1 to 1. So next what they asked us to find, F composition G. We have to find whether F composition G is 1, 1 or not. So we find F composition G. See what is F of x? X raised to 4. G of x, F is x raised to 5. G is x raised to 4. F of x is x raised to 5. G of x is x raised to 4. So what do you have to calculate now? We have to find F composition G. We find F composition G of x. What is F compose G of x? How can you find F compose G of x? F of G of x, right? You can write it as F of G of x. F of g of x. That is f of, what is g of x? X raised to 4. That is, put this value in f. What is f? X raised to 5. So here x raised to 4 raised to 5. You know there is a formula, a raised to m, the whole power n. What's the answer? A raised to mn. A raised to mn. So here what you get? X raised to 4 into 5. What is that? 20. So can you tell me x raised to 20? What can you say? It is 1 or not? Just try. What's the power here? The power is what? Power is 20, right? So the power is 20. So if we give some example, f composition g of 1. If we give 1 here, 1 raised to 20. So the answer is 1 only. Then you find f composition g of minus 1. You are getting minus 1 raised to 20. Minus 20 times, that is also plus only. So plus 1. So two different elements have the same image. So again, you can say it is not 1, 1. So the answer f composition g is not 1 to 1. So you know how to check the function is 1, 1 or not. Okay. So now we go for the next question. Look at this question. Consider the functions, 3 functions given here, f of x, g of x, and h of x. Show that f composition g composition h is equal to f composition g composition h. So 3 functions given here. They asked us to verify f composition g composition h. So first we find LHS, that is f composition g composition h. So for that, first you find the term inside the bracket. So what is the term inside the bracket? F composition g, right? So first you find f composition g of x. That is f of g of x. That is f of, what is g of x here? G of x is what? X square, right? So f of x square. Put this value in f. What is f? F is x minus 4. F is what? X minus 4. So here you give the value x square. So what answer you are getting? X square minus 4, right? X square minus 4. This is f composition g of x. So this part you got it, f composition g. Now the whole thing, f composition g composition h. F composition g composition h. So what's the method here? You know, you have to put this h value in what? F composition g. You have to put this f composition h value in what? F composition g. Okay, see how to do this. So this f composition g, write as it is. F composition g of h. What is h of x? What is h of x given here? H of x is what? 3x minus 5. 3x minus 5. This 3x minus 5 is substitute where? F composition g. What is f composition g? It is x square minus 4, right? F composition g is, what is given here? What we got it? X square minus 4. You substitute there. X square minus 4. X square minus 4. So can you simplify, substitute the value? Here you give what? 3x minus 5. 3x minus 5. So now this is a minus b the whole square type. So what is a minus b the whole square? A square minus 2ab plus b square. This is a minus b the whole square. Then finally we have a minus 4 also, right? Minus 4. A square, instead of a we have 3x minus 2ab, a value 3x and b value 5. Don't put minus 5 because minus already we considered here, right? Okay. Now here b square, b value what? 5 square. Simplify this. This is 9x square minus, multiply all the 3. 2 3s are 6, 6 5s are 30, right? So 30x. Plus that 5 square is 25 minus 4. So what answer you are getting? Group the like terms. So 9x square minus 30x. 25 minus 4 is what? Plus 21. So this is the answer for LHS. This is F composition G, composition H, right? Now we find the RHS. What is RHS? F composition, G composition, H. F composition, G composition, H. So next we are going to find F composition, G composition, H. Okay. So we find F composition, G composition, H. So for that, first you find the term inside the bracket, right? So what do you find? G composition H of X. That is G of H of X, right? G of H of X. G of, what is H of X here? What is H of X given? 3x minus 5, right? So 3x minus 5. Put this value in G. What is G here? G is what? X square. So you write x square. What is x? 3x minus 5, which can be simplified, right? You can simplify this. How can you write this? This is equal to a square. So that is 9x square. A square minus 2ab. 2 3s are 6, 6 5s are 30. So write 30x plus b square, it is 25. So this is what? G composition F. But what we have to find? So we have to find F composition. We have to find F composition, G composition, H. So what's the meaning of this? You have to substitute this G composition H in what? F. You have to put G composition F in what? H. Sorry, G composition H in F. So that is that you can write it as what? You can write it as F of. So you can write it as what? F of G composition H. What is that? That's answer, you got it here. 9x square minus 30x plus 25. So this lengthy value is substitute in what? You substitute in F. You have to substitute this value in F. What is F of X? What is F of X here? X minus 4. It is X minus 4, right? So you have to write it as X minus 4. Instead of X, what do you write? The value. What is that? 9x square minus 30x plus what? 25. So you simplify this, you are getting 9x square minus 30x plus 25 minus 4. When you simplify, you are getting 9x square minus 30x plus 21. So that is number 2. Now we check it. Are they same? For the first one, 9x square minus 30x plus 21 for the first one. For the second one also 9x square minus 30x plus 21. So what you can say? From 1 and 2. From 1 and 2, F composition G composition H is equal to F composition G composition H is verified. Both answers are same. Okay, so composition of function is not commutative, but composition of function is associative. Here they asked us to prove F composition G composition H is equal to F composition G composition H. This question can be asked in another way. How? Verify associative property. If you don't know the name, then you may find difficult, right? So remember the name of the property. It is associative property. It's very important. You have to practice more questions in this type. Look at the next question. It's a different one, but it's a very simple question. F is equal to, F is a function, minus 1, 3, first value they given what? Minus 1, 3, then 0, minus 1, and 2, minus 9. What's the meaning of this, Image of minus 1 is what? 3. Image of minus 1 is 3. Minus 1 is related to 3. And image of 0 is what? Minus 1. And image of this 2 is what? Minus 9. This is what given in the question, okay? So what they asked us to find, be a linear function from Z to Z. What is Z? Set of integers. What are integers? 0, 1, 2, 3, 4, minus 1, minus 2. So that is set of integers. Z into Z. Find f of x. F of x is the linear function. We have to find the linear function. So let the linear function be. We have to find the linear function, right? Let the linear function be. We take the function as say f of x. F of x is equal to ax plus b. F of x equal to ax plus b or y equal to fx. So you can write even y. Y equal to ax plus b. This is your final answer. But there are two unknowns. What are the two unknowns? The unknowns are A and B. The unknowns are A and B. We have to find that A and B. So for that, we make use of the points. What are the points given here? -1, 3. So we use the point -1, 3. What's the meaning of that? For x you put -1 and y value or fx value 3. For x you put -1. So for x you give -1. So -1 into A. So -A plus B equal to the y value. What is y value here? 3. So this is one equation. Now we have 3 points, right? So first point I used. Now you can use the second point. What's the second point? 0, -1. Now we use the point 0, -1. Or the third, anything. But this will be easy because 0 is there, no? So one part will be 0. You easily get the answer. For x you put 0 and y value -1. For x you put 0. So 0 into A. It is what? 0 plus B. Instead of, so B you write B itself plus B equal to y. What is y? Y value here it is what? -1. So you are getting B is equal to -1. So B value got it. So now we want A also. For that you substitute this value in the second equation. In the second equation, -A plus B, right? -A plus B equal to 3. -A plus B, B value -1 equal to 3. Or you can say -A is equal to 3 plus 1. So -A is equal to 4, and you are getting A is equal, change the sign, A is equal to -4. So you got the values of what? A and B. But that is not the final answer, right? You have to find the linear function. Linear function is the equation number 1. So you substitute these values in the first equation. Y is equal to AX plus B, right? Y is equal to AX plus B. Give the values. That is Y is equal to A value. What is A value? -4x. Plus B value -1. So minus is common. So if you want the last step, minus you take outside, you will get 4x plus 1. And this is the required linear function. Okay, now we'll see just one more question. This is entirely a different one. Okay, but it's a very simple one. I'll tell you at the same time, it's very, very important. Okay, look here. F and G are two functions. F and G are two functions. F they have given us 0, 1, 2, 0, 3, -4, 4, 2, 5, 7, right? 5, 7. So this is a function F. F is this function. And G is another function. G is another function. 0, 2. First element is what? 0, 2, 1, 0, 2, 4. Then -4, 2, 7, 0. What they asked to find? Find the range of F composition G. They asked us to find the range of F composition G, right? Listen, before writing range of F composition G, I'll explain to you how to find F composition G. So listen very carefully. F composition G means you have to start with G to F. So what you do first, you start with G to, you have to go what? F. G to F. So what's the meaning? You take the first element in G. What's the first element in G? 0. 0 is related to, the input is 0. What's output? 2. Then this 2, the image must be the input for F. This 2 you have to look here. The first element to S, it is here, right? So please listen again. You start from G. In G, the first element is what? 2. Sorry, first element is 0. That 0 is related to what? 2. Now for that 2, you find the image in F. In F, 2 is here, right? 2 is here. What is this image? 0. So here, you start with 0. What's the image of 0 under F composite G? 0 is related to 2, and that 2, you see here, that 2 is related to 0. So the answer 0, 0. So that is the first one. I'll explain the next one, so I'll get some idea. What's the next one? First element, 1. So 1, what's the image of 1 we are going to find? Okay, so 1 is related to what? 0. Now 0 you have to see in F. Yes, here, 0. For 0, what's the image? 1. So here you write what? 1. Look again. This 1 you take. 1 is related to 0. 1 is related to 0. And the 0 you see here, the 0 is related to 1. Okay, so that one is your answer. Now take the next number. Next number is what? 2. In G only you have to start 2. 2 is related to 4. Now this 4 you look into F. The 4, yes, here you have 4. The 4 is related to what? 2. And that 2 is the final answer here. And the next one you take what? Minus 4. Minus 4 is related to 2. Minus 4 is related to 2. And that 2 you see here, already we have taken that. That 2 is related to what? 0. So here you write what? 0. And the last one you see 7. 7 is related to 0. And 0 you check. Yes, 0 is here, right? 0 is related to 1. So 7, 1 you write. Okay. So like this you have write F composition G. If they ask F composition G, this is the answer. But they asked what is the range of F composition G. Range of F composition G means only the answers you write without repetition. So what are the answers you have here? You see, find out what are the answers you have. You have 0, 1, 2, 0, 1. Without repetition you write 0, 1, 2, right? 0, 1, 2. Again 0 and 1 only, so you can no need write that. Okay, so this is the answer for this question. But just to explain to you the same question, so how to find what? G composition F, that you can try, right? G composition F means you have to start from where? F you have to start. So in F you find out what's the first element. F, what's the first element? 0, right? 0. Then 0 is related to 1. 0 is related to 1. Then that 1 you see here, that 1 is related to 0. So the first element is 0, 0. For the second one, the first element is what? 2. So you write here 2. 2 is related to 0, right? 2 is related to 0. And that 0 is related to 2. So the answer is what? 2. Next one, you take this 3, right? So you take 3. 3 is related to minus 4. And that minus 4 is related to 2. So 2 you write. Next number, what's the next number here? 4, right? So 4. 4 is related to 2. 4 is related to 2. And that 2 is related to 4. So write here 4. And the last one, 5. And 5 is related to 7. And here the 7 is related to 0. So finally you write what? The 0. So like this you can find G composition F. Here if they ask range of G composition F. So second elements you take 0, 2, again 2, 4, 0, right? So without repetition you write 0, 2, 0, 2, again 0, we have written 2 already written, then this 4 you write, right? This is range of G composition F. But in this question, they asked only what? They asked to find only the range of F composition G. So this is your final answer. So hope you got the clear idea about composition of functions. We'll see you in next video.